Hey folks, welcome back to the channel. Project for the house we're working on today, we're going to start getting set up to build the stairs. Rather than wait on carpenters to show up to do the framing to get stairs built, we're going to go ahead and build them out of steel. We've decided that we like the aesthetics of that, and it's something that I can knock out a lot faster, and the cost will be about the same on material, and labor is going to be a zero because it's me and my dad doing it. So we're gonna get y'all set up, and you can watch us start getting this saw set up and get everything ready to go. To make cutting up this steel for these stairs a little bit easier, we're setting up a roller deck that was out behind the shop from another job quite a while ago, and my dad took a bandsaw off of its stand at the shop, and we're going to mount it on the end of this roller deck so we can pick up the material, roll it into the garage, and cut it to length.
I got it. We'll get up in there. You're heavy on your end.
Yeah. Not by much though.
No.
You can drop it down.
You gotta swing that way, drop the boom down.
Yeah, you can try it, but
Coming back. Yes, I will be going to Mr. Baker's and see if any of the hydraulic cylinders are still out there.
oh,
Alright, that's all I can do with it.
okay, well then you're gonna have to give me slack and let me
Yep.
pull it in.
Okay, you got it. What it's doing is it's bouncing and come by it. That's pretty good right there. Let's check the middle of it and see what. Now, we've got to come up a half inch on that side and a quarter inch on this side. Can you see it? Then, yeah. Anyway,
Okay, we are actually pretty level.
That's on top of the cliff right there. Once we get these to elevation, get the box squared and tie these two corners in, then we figure out what it's gonna take.
Here we're starting the process of placing the embeds that you saw me build in a previous video that go around the stair opening. And we're using this set of embeds as our benchmark to set the elevation for grade that determines the thickness of the concrete on the second floor. A little bit later in the video, you'll see us doing the same thing in the garage, and you'll see us using a laser level that we have set to this grade, and then we'll transfer that height to the set in the garage, and it gives the guys placing the concrete something to use as a screed guide to get the thickness of the concrete consistent across the whole second floor.
Ain't bad for guessing. But,
So we need to move 1/8 of an inch that way.
alright, then 44 and 5/8. Alright.
Well, and if we get it tight, I got a long enough clamp, we can pull it to get it squared.
Right, yeah.
If we get it tacked.
Not hooked together. How many of them pins in there?
$70 and 5/16. $70 and a half. So we need to go that way, 1/4 of an inch, a little less, or come this way.
Go. Put this in there. Alright. Did you come my way?
No.
Your way.
So that's at 70 and 5/16, so we're gonna need to
That's what we want. Just a little bit.
for 70 and a half.
Okay. I just touch it, but I knocked it a long way. Right to 3/8, you should be there.
70 3/8. 70 and 3/8.
All right.
Don't get it over by your truck, because if it slips, it's just gonna beat the crap out of your truck.
I got it. It's about halfway decent.
Yeah. Oh! Let me see what we got.
Go down a little bit more, looks like back to the left a little.
Yep, swing north. We need to move about a foot.
Okay, lay it easy, trying to.
One more bump. Oh. All right. Well, we can do it with the cable from there. I just got to pull it back. Come on. Easy. All right, cable down. Yeah, oh, oh, oh. We're just a hair too wide up here.
Piece this.
Yeah. I think we can cable it down at an angle. Get it past it and then drop it over.
Okay, so what do you want to do?
I'd say try cabling down. We may end up just beating the thing down the freaking wall. Try booming down. Oh. The problem is the concrete's sticking out up here at this top.
Okay, we'll try to tip it like you're talking about. Get me out of the bind and do it now.
Yeah, let it on down. Stop. Yeah, this freaking wall is wide, but I think I can hammer it down. It's not that much. All right. Down just a bump. Oh. Hey, it fell off of the thing.
Yeah, it did.
Hang on, we're gonna have to do one end or the other,
Okay.
all the way up to clear.
Stop and let me get up so I can go all the way up. I think it's like work one end at a time.
That says we're high.
See how much I.
That says we're low. Actually, what that says,
It says you gotta go up.
no,
Huh?
what that says is, once I get this level, we're right on. I'm getting ready to start the layout for the stringers on this set of stairs we're putting in. And what I need to do is make sure that the angle of these treads or the stringers match the bottom. This is a fixed point. We have some leeway with the bottom, so we're going to use this to work off of. And there's two ways you can figure out this angle. One, you can use a digital level, and you get your point where your stairs end at the top, and then the bottom where they end on this landing, and you can put your level on there, and that shows me we've got a 40-degree angle. Okay? The other way you can do it is if you have a speed square. You can use your speed square because you've got degree measurements along the longer open leg, the hypotenuse of the triangle. The way you use this speed square, you want to get it vertical over here, which means you're going to need a level, right, to make sure that you're vertical. And then you read your degree measurement on this hypotenuse once that leg is level and you're on the corner where everything comes together. And that'll tell you we're at 40 degrees. I already know that because I'm using the digital level. Since we've established our angle on the upper section, you do this basically in the reverse order because we had a fixed run up there. We don't know what our run needs to be down here to make the angle match so that when you're walking on the stairs, it's not inconsistent from top to bottom. So what you do, the easiest way is with your digital level. Get your digital level, get your board or level or whatever you're using to figure this out on the top of that platform, and then you just start sliding it out until you hit your degree angle that matches what you had on the top. So here we are, we're 40 degrees. And that lets you then figure out what your end point is for your run on the lower section of stairs. Now, if your platform is exactly halfway between the floor and the ceiling, it should be the same. This is not. This is actually a little higher because we're going to use this area for storage under the stairs. So once we got our end point established to have the right angle on our stringer to make it match from side to side, I'm using a square. Because this block is so uneven on the surface, I'm using this level to give me an average across this surface that I can square off of. Then I lay the square in the corner, get this level squared to that, and then move it back and forth until I hit my end point, which will then give me the same end point on the other side. On an average set of stairs, by code, you want to be about 7 inches plus or minus a little bit on your rise between stairs or between steps on the tread. So what we're going to do is take a set of calipers or dividers and step this thing out to get our averaged distance between each step. So that way we can then take that measurement and transfer it from one stringer to the other, and then from the top section to the bottom section so that they match. So 6.84 inches gives us 11 steps. So we've got
9 treads.
Yeah, 9 treads. So if we divide 75.25 inches by 11, which is what was working out, we were thinking it was going to be 10, it gives us a step that is 6 7/8 between treads. So that's still within code. I mean, you've got some tolerance in there. We don't have to build the code because we're out in the county, but we're trying to make it kind of future-proof by doing all of this stuff.
Come down a little bit.
Yeah, but now we're,
Yeah, I'm good.
now we're slipped that way a half inch. We got to come back this way.
Okay.
That's what we need right there. Nope, we need more than that. Hang on. Come this way. All right. Right there. Can you hold it?
Let's slip it. See if you can get it past the top.
Or anywhere it's touching. Oh. Let down. I'm trying to. That's got us right against the corner. Oh, right there. So we went to cut the 12-inch channel for the stair treads and discovered that even though this saw says it'll cut 12-inch material, it's not quite wide enough. So we're having to clearance it to get it to go past the leg on the channel so we can cut it. Because it's not tall enough to cut it vertical, and then you can't really clamp it anyway. That looks pretty good.
Let's get the 12-inch channel up here.
brush all that.
That's pretty good side to side. So what I'm trying to figure out is how to cheat the space between these steps to keep them within tolerance so you don't notice it going up and down. Because of the way that the architect drew this thing, we made the stringers to match what they said on the drawings. Problem is, the drawings are not accurate. One, the number of treads is misnumbered. Two, the distance from opening to foot of the stringers doesn't work out, because if you scale the drawings out in the middle of the run of stairs, they've got it at 7-inch rise. Well, the problem is it's 9 inches on the bottom and 9 inches on the top if you scale it out. If you try to do the math and work it out, it doesn't work out to 7 inches. It works out to 7 5/8 to 7 3/4. And this material is so inconsistent that you can't rely on using an edge on this, because their dies are worn out, the material's warped, the material's twisted, the thickness on this flange varies from piece to piece and one end to the other. So I'm having to kind of fudge this around to make it work. And it's just aggravating as all get out, because steel used to be a lot more reliable in its dimensions than wood. But post-COVID, Americans don't give a crap. Since we pretty much got the rise and run established, I'm just giving myself some guidelines over here to give me a starting point for putting the clamps on, and then I'll measure and level everything from side to side and front to back. And the lines I'm wiping off are previous iterations of trying to figure out what was going to work. Because ideally you want about 7 1/4 inches. That's about the perfect rise. 7 to 7 3/4 is what they say to use in residential applications. We're getting toward the top end of that, because we're running at about 7 5/8 to 7 11/16. Yesterday, I didn't record it, but I laid this thing out about 5 or 6 times, using different rise, trying to get it so that we had a livable step distance from top to bottom, because with the numbers being all jacked up on the drawings, you couldn't just do 7 inches from top to bottom. What you ended up with was, if you had a 7-inch step at the top, you ended up with a 2-inch step at the bottom, or I don't remember what all, you know, I did so many different iterations of it until I finally settled on about 7 5/8 to 7 11/16 to make it so that the treads were even all the way up, or within a tolerance that you wouldn't notice the difference. All right, that was the last stair tacked in, so now I need to start welding them in. I thought I'd take you on a trip. This is coming in the front door. These are the stairs going up to the 2nd floor. There's the 2nd floor. And then looking back down the stairs toward the door. All right, folks, I think that's going to wrap this video up for today. Thank you for watching, and y'all have a good day.